Welcome to this Solid Edge podcast, bringing you quick and easy tips and tricks from the experts. In this week's show, I'm joined by Mark Thompson, who will show you how to extract a mid-plane surface in Solid Edge simulation and then mesh it with surface elements. To mesh a part like this with solid elements would require a larger model to attain any degree of accuracy. By creating a shell element model, a high degree of accuracy can be obtained, with fewer elements producing a much smaller and more efficient model. Let's see how it's done, Mark.
I've constructed a sheet metal file in Solid Edge ST3 with synchronous technology. And what I want to do is run a quick analysis on this. So what we'll do is we'll switch over to the Simulation tab, because simulation is built right into Solid Edge. And you'll notice also that we can create a mid-plane surface. Now this surface is going to represent this sheet metal body, and all we have to do to create is identify the face we want to create it from, and then it will automatically create that surface for us. Now in order to do this and be able to see that surface, I'm going to go ahead and hide the design body. And then we can kind of focus in on this surface. Let's go ahead and create a study. It's going to default to a mesh type of surface because that's what we're looking at. And then we can identify that surface very quickly. You'll notice the rest of the commands become active, so let's go ahead and apply a force to this top face. We can change its direction to a downward direction, and then we'll go ahead and apply a fixed constraint to the back face just to get through this quickly. Once we're done, we can go ahead and create a mesh, hit the solve command, which will automatically run the mesh, and then the solve, and then it will create the results, giving us feedback immediately. Now the neat thing here is that the mid-plane surface is associative back to the solid body. And also the cool thing here is that because simulation is built in to Solid Edge, it's going to automatically reflect that in the results. So once those results are visible, we can actually close and return. And let's just say we want to make a quick change. I can actually show that design body. And then we'll use synchronous technology to, say, for example, identify the side of this particular model. And let's say I want to reduce its width by about 40 millimeters. We can do that very quickly. And then I can grab this front face, and maybe I want to extend the tongues out on this fork. And let's bring that out about 40 millimeters. You'll notice that the force automatically adjusted itself, and in fact the study is still intact. It understands the thickness from the mid-plane surface, but the mesh and the results are out of date, and that's because I've changed the model. So if I run the solve again, it'll remesh, resolve the model, and then create the results again very quickly. Again, the beauty of this is everything's built into Solid Edge ST3 with synchronous technology, and the mid-plane surface is also associated back to the model. So any synchronous changes that we make to the model will be reflected automatically in the results. This makes it very easy to use within Solid Edge.
Thanks for showing how to efficiently analyze sheet metal components or parts with a thin-walled section. To learn more, go to siemens.com/solid edge or call your local Solid Edge channel partner.